Once the design space geometry is created, the next step in optimization follows the Structures toolbar logically from left to right. The model building process starts with defining interactions between bodies, then external loading, and lastly applying materials. Inspire includes multiple methods to accurately connect bodies in the model, such as fasteners, joints, rigid or flexible connections, spot welds, and contacts. Interacting with connection interfaces is intuitive. Minimal clicks are required as Inspire suggests where connections are appropriate. In this case, screw connections are generated between all aligned holes within our search tolerance. Choosing the Find Parts and Holes option will suppress the actual geometry to speed up the run times. Joints restrain motion between bodies, such as a pin connection, to constrain the motion of a shaft relative to a bore. Connectors can replace bodies for faster optimization of the actual bodies of interest. They are used to apply loads at a distance or to connect faces. Depending on the fastener or joint definitions, Inspire will intelligently choose the appropriate contact relationship. In this case, the bolted faces should have a contacting relationship rather than a bond for proper load transfer. With the relationships between the bodies defined, it's time to define the external loads and restraints. Supports and loads are applied to faces, edges, and vertices, and the directions adapt based on the geometry shape. Orientation and degrees of freedom for the loads are indicated via intuitive feedback for adjustment if needed. It is important to capture the different types of loads our system will encounter to drive the optimized design. Inspire users can apply multiple loads and load types along with different supports. These can be organized into different load cases that represent the use of our design. Lastly, materials are applied to the bodies, using the material table or interactively part by part. Now the model is ready for an analysis or to begin setting up optimization constraints.